Good morning, students. Today we will discuss the topic that is the bridges, DC bridges, and the topic is the Kelvin bridge. Okay. In this lecture today we will discuss the Kelvin bridge, and then we will discuss the Maxwell bridge. We will discuss the types of the AC bridges. That is the Maxwell bridge. We will start with the Maxwell bridge. So today, yesterday we have done the topic that is the introduction of the bridges. What are the advantages of the bridges? What are the applications of the bridges? Then we will discuss the type of bridges. Okay, there are the two type of bridges: AC bridge and the DC bridge. DC bridge is basically or is of two type. One is the Wheatstone bridge that we have discussed yesterday, and today we will discuss the Kelvin bridge. Okay, students. So today Kelvin bridge is the like a in Wheatstone bridge. While measuring the low value resistance, the resistance of their lead and their contact increase the resistance of the total measured value. So in the Wheatstone bridge, there is the one drawback that when we are measuring the low value resistance with the help of the Wheatstone bridge, the resistance of the leads which we are using in the experiment, okay, that increase the resistance of the measured value. Okay, means we have to measure the value of the 0.001 kilo ohm, 1.001 ohm resistance. Okay, so when we are performing this experiment with the help of the Wheatstone bridge, the connecting leads which we are using to connect the resistance or the load, it increases the value of the load resistance. So this is the one drawback in the Wheatstone bridge. To overcome this drawback, we are using the Kelvin bridge. To overcome this drawback, we are using the Kelvin bridge. Okay, students. So this is the circuit diagram of the Kelvin bridge. Kelvin bridge is of two type. First one is the we are having a simple Kelvin bridge. Then second type we are having a Kelvin double bridge. Okay, so this one is the Kelvin bridge. Okay, this is the circuit of the simple Kelvin bridge. It is the DC bridge. Okay, again I am repeating, this is the type of the DC bridge. We in this circuit diagram we have connecting this E as the DC source to this bridge. Again it is having the four arm. First one we are having a PR, then we are having a QR, then we are having a RR, then we are having the SR. Okay, so this is the galvanometer which we are using as a null detector. So again I am repeating, we are using the source and the one as a detector in the bridge. Source we are using the DC source, and the detector we are using here is the galvanometer. So this is the circuit diagram of the Kelvin bridge. But there is the one problem in the Kelvin bridge, that the galvanometer is connected to the point D, and along its opposite side there are the three connection. One is the point M, one is the point D, one is the point N. Okay, so there is the problem where we will connect the galvanometer either to the point M, either to the point N, or either to the point D. Okay, so there is the problem which we are using here. Like with the help of connecting leads, we are connect the galvanometer either to the point M, either to the point D, either to the point N. So where we will connect this galvanometer at the opposite side, we will connect the galvanometer to the point M, we will connect the galvanometer to the point D, we will connect the galvanometer to the point N. So we are having a like a the R is the resistance of the contact that connect the unknown resistance R to the standard resistance S. So here we are having a R is the resistance that is here R, this R is the resistance from the wire M to D. We are having a resistance R1. From the N to D, we are having a resistance R2. Okay. So R is the resistance of the contacts. Okay. R is the resistance of the contacts that connect the unknown resistance R to the standard resistance S. The M and the N are the range between the galvanometer connected to the null point. So we are, again I am repeating, we are having a two options. We will connect the galvanometer either to the point M or either to the point N. So when the galvanometer is connected to the point M, the lead resistance R is added to the standard resistance S. So now I am considering the case one. I am connecting this galvanometer to this point M. Okay. So what will be happen when I am connecting this galvanometer G to the point M? Then this resistance of the wire, okay, this curve resistance of the wire, that is the resistance R, it is added to the resistance S. Okay. So this resistance R from the point M to the point N, this wire resistance R, it is added to the resistance S. This is added to the resistance S. Okay. So this is the drawback. Again, if I am connecting the galvanometer to the point M, the resistance of this wire is added to the this standard resistance S. Okay. So this is not possible. We will not connect the galvanometer to the point M because the resistance of M to N, that is the R resistance, it is added to the resistance S. Okay. So next is the, we will connect the galvanometer. Okay. We will connect the galvanometer to the point N. Okay. So when we are connecting the galvanometer to the point N, then suppose that this is the galvanometer, this is the second point. We will connect this second point to the point N. Okay. So what will be happen here if I am connecting the galvanometer to the point N? The resistance of this M to N, that is the R resistance, it is added to the this capital R resistance. This will be added into the capital R resistance. Okay. So we have to measure this R resistance, and this R resistance from the point M, small r resistance from the point M to the point N, it is added into this R resistance. Okay. So that is the again a problem. Means this, we have to measure the unknown resistance capital R, it is added into the resistance small r is added to the capital R. So we are not connecting the galvanometer to the point N. Okay. So we can't connected the galvanometer to the point M. We can't connect it to the galvanometer to the point N. So what is the, where we will connect the galvanometer? So we will connect the galvanometer. So instead of connecting the galvanometer to the point M or to the N, we will choose the intermediate point D. We will connect the intermediate point D, where the resistance of lead R is divided into two parts, R1 and the R2. So what we will do, we will not connect the resistance galvanometer to the point M. We will not connect the galvanometer to the point N, because if I am connecting the galvanometer to the point M, the resistance of this wire from M to N, it is added to the point S, and when I am connecting the galvanometer to the point N, the resistance of this M to N is added to the resistance R. Okay. So we will not connect the galvanometer to the point M. We will not connect the galvanometer to the point N. We will choose the intermediate point, that is the point D. We will connect the galvanometer to the point D, and the resistance is the M to D is the R1 and D to N is the R2. Okay, we are having a two part resistance R1 and the R2. So the presence of R1 and the R2. Now, if I am connecting the galvanometer to the point D, the presence of R1 and the R2 does not affect in measurement of unknown resistance. Means we have to measure the small value resistance, and we will not connect this R1. We will not connect the galvanometer to the point M to the point N. We will choose the point, intermediate point, that is the point D, and the resistance of R1 and the R2 from the point M to D, like this one, from the resistance M to D or D to N, R1 and R2, it does not affect the unknown resistance. Unknown resistance is capital R. We have to measure this R1 and R2 from the point M to D. So we will discuss that. We will not connect the galvanometer to the point M. We will not connect the galvanometer to the point N. We will connect the galvanometer to the point D. So, because we have to measure this unknown resistance capital R, and when we are connecting the galvanometer to the point D, the resistance, this R1 resistance and this R2 resistance will not having any effect on this capital R resistance. Okay,
Sir,
so this is the advantage of connecting the galvanometer to the point D. So next we will solve the equation of this Kelvin bridge. Okay, so to solve this equation of this Kelvin bridge, we will take R1 and R2 ratio is equal to P upon Q. Okay, again I am repeating, we will taking the ratio of R1 and R2 is equal to P upon Q, and we are solve this equation according to the basic of the Wheatstone bridge. So I will solve this equation beta on the board. So this is the circuit diagram of the Kelvin bridge, which you are seeing on the PPT also. So we are connecting this galvanometer either to the point this M or either to this point N. But we are not connecting the galvanometer to point M or to the point N. We will connect the galvanometer to the point D. Okay, because when we are connecting the galvanometer to the point P, the resistance of this R1 and the resistance of this is R2 does not affect on this unknown resistance R, which we have to measure. Okay, this is the unknown resistance which we have to measure. Now
Sir,
moving toward the equation of the bridges. So we are having,
sir,
according to the this bridges, we are having R1 upon R2. That is the ratio of this resistance from the point M to the point D, from the N to the point D. That is the R1 upon R2 is equal to P upon Q. This ratio arm R1 and R2 is equal to the ratio arm of P and Q. Okay, beta. So this is the ratio arm R1 upon R2 is equal to P upon Q. Now we are having the equation like a Wheatstone bridge. What is the equation of the Wheatstone bridge? P upon Q is equal to R upon S. We are having P upon Q is equal to R upon S. This equation we have derived yesterday in the Wheatstone bridge. So ratio of the opposite arm is equal. Ratio of opposite arm is equal. With the help of this formula, we will calculate the unknown resistance. So here we are having a, like this one is the R plus R1, the resistance of this arm, that is the R plus R1, because from point this to the point this one, okay, we are having a resistance. This is the unknown resistance R. From this point to this point we are having a resistance R. Again from this point to the this point we are having a resistance R1, small r1. Okay, so this is equal to the P upon Q. Then we are having a, you can also write this equation like this one. Ratio of opposite arm means this arm and this arm, we will write down here Q. Okay, this is the resistance of this arm, and from this arm to this arm opposite arm resistance is equal. This is equal to the, now we will take the P, here we will write down the P, and ratio of this arm, ratio of this arm. Okay, so this is the S plus R2. We are having S plus R2. Okay, so I can write down this equation as R plus R1 is equal to P upon Q S plus R2. Okay, so this is the equation which I have written in this form. Ratio of opposite arm is equal to this one, R plus R1 P upon Q R plus R2. Or when we are solving this equation, okay, so when I am solving this equation, when I will do the, first of all I will do the cross multiplication here. Then after doing the cross multiplication, you can divide it, putting the value, first of all R1 plus R2 is the R, by using this formula, means this R1 and this R2 resistance, this total resistance is the small r. Okay, so when we are putting this value to solve this equation, the unknown resistance will come P upon Q. R is equal to, R is the unknown resistance, R is equal to P upon Q S. Okay, so we will derive this formula, R is equal to P upon Q S. Okay, students, so you can, using this the two identities, we will solve this numerical part, derivation part. Students, one thing more, the numerical came on this bridge. Okay, so in the numerical part, like you have given the value of the P is 10 ohm. Okay, Q is equal to 20 ohm.
चलो
Then
चलो
R
दिखाई नहीं दे रहा
you have
सर
to find
विजिबल
out.
नहीं है सर
S is
सर
given
नीचे
like
करना
a
है
30 ohm.
विजिबल नहीं
तो
है सर
दिखाई नहीं दे रहा
Yes, beta. Any doubt?
सर नीचे
सर थोड़ा
विजिबल
कैमरा नीचे कर दो दिखाई नहीं।
थोड़ा कैमरा
सर नीचे
नीचे
करना
करना।
है कैमरा।
So we are having R is equal to P upon Q S. Okay, beta. So numerical came in the like a paper, like you are having the value of S is 30 ohm, P is equal to 10 ohm, Q is equal to 20 ohm. So what is the value of unknown resistance in this case? So you simple put the value here. R is equal to, R is the unknown resistance, P value is the 10 ohm. Okay, and what is the value of the S? That is the 30. Okay, Q value is the 20. So
15
it is like a 30 by 2, 15 ohm. Okay, you can drive, you can solve the numerical like this one. This is clear to everyone or not?
सर क्लियर
Means in the numerical you have given the value of the small r1, you have given the value of the small r2, but that are the useless. Okay, that are not used in the numerical, that values are not used in the numerical part. So you simple put these values in this equation and you will solve the numerical. Okay, so this is the like our first bridge, that is the Kelvin bridge.
हेलो सर हेलो सर
Next we are having like
हेलो सर
next bridge we are
हेलो सर
सर सर
yes beta.
सर सर ये कैसे जानेंगे हम कि ये इसको सर केल्विन से बनाना है या फिर व्हीटस्टोन ब्रिज से? सर दोनों का सर फॉर्मूला सेम ही आ रहा है।
So next type of bridge we are having is the Kelvin double bridge. Kelvin double bridge is the modification version of the Wheatstone bridge, which can measure the resistance value, that is from the 1 to 0.001 ohm. So it is Kelvin bridge is like a Wheatstone bridge. It is a DC bridge, and it is used to measure the value of the low value resistance from the below to the 1 ohm and to the 0.001 ohm with higher accuracy. The accuracy of measuring the low value resistance of Kelvin bridge is very high. Okay, so the basic operation of the Kelvin bridge is the basic function, the basic operation of the Kelvin bridge can to understood the basic construction and the operation of the Kelvin bridge. So we can say that ki Kelvin double bridge is basically derived from the Kelvin single bridge. Okay, and it is used to measure the accuracy very accurately.